In this lesson, we're going to be exploring angle pairs. The objective is to identify special angle pairs and use their relationships to find angle measures. The first angle pair that we have are adjacent angles. Adjacent angles are two coplanar angles with a common side, a common vertex, and no common interior points. Let's draw an example. Let's draw angle ABD and angle BDC. So these two angles, ABD and DBC, have a common side, which is ray BD. They have a common vertex, which is B, and they share no common interior points between the two of them. Next, we have two angles whose sides are opposite rays, and those are called vertical angles. An example here, basically you just have two straight lines that cross, and those two opposite angles are vertical angles. They form straight lines because those are opposite rays. One thing that will help you remember that they're vertical angles is that they form a V. So that'll help you remember V for vertical. Next we have complementary angles. And those are two angles whose measures have a sum of 90. Each angle is called the complement of the other. These two angles do not have to be adjacent. They can be two totally separate angles that just add up to be 90. So they could be a 40-degree angle and a 50-degree angle. And those would be complementary. Angles whose measures have a sum of 180 are supplementary. Supplementary angles. And each of those angles is called a supplement of the other. Once again, do not have to be adjacent. Could be a 70-degree angle and a 110-degree angle that are totally separate from each other. Their sum is 180, so they are supplementary. Next we have a pair of adjacent angles whose non-common sides are opposite rays. Those are called a linear pair. So let's look at an example of a linear pair. We have angle ABD here and DBC. And those two angles are a linear pair because ray BA and ray BC are opposite rays. And those are the non-common sides of the linear pair. The common side is ray BD. The angles of a linear pair form a straight angle because they form a straight line. The linear pair postulate indicates that if two angles form a linear pair, then they are supplementary. And our last definition is a ray that divides an angle into two congruent angles is called an angle bisector. Here, ray AY is the angle bisector of angle XAZ because it divides the angle into two congruent angles. In problem 1, we're identifying angle pairs. We're going to use the diagram and determine if each statement true and explain why it is or why it is not true. So the first question, A, is asking about angle PAL and angle LAM and asking if they are adjacent angles. that is a true statement. You have to explain why. It's true because they have a common side, a common vertex, which is A, and they have no common interior points. Question B is about angle PAO and angle NAM. And it's indicating, are they vertical angles or not? That is false. They are not vertical angles because ray AM and ray AO are not opposite rays. Question C is asking if PAO and NAO are supplementary. That's true because 74 degrees, which is the measure of angle PAO, and 106, which is the measure of angle NAO, when you add those together, the sum is 180, which is the definition of supplementary. In the next problem, we're making conclusions from a diagram. So what can you conclude from the information in this diagram? First, let's look at angle 1 and angle 2. Because of the congruence marking, we can conclude that angle 1 is congruent to angle 2. From the other definitions of pairs that we have been studying here, angle 1 and angle 2 are also adjacent angles. So let's work our way around because there are other pairs of adjacent angles. Angle 2 is also adjacent to angle 3. Angle 3 is also adjacent to angle 4. Angle 4 is adjacent to angle 5, and angle 5 is adjacent to angle 1. So all of those, I'll put ditto marks, are adjacent angles. What other special pairs of angles do we have in the diagram? Angle 3 and angle 5 are vertical angles because their opposite sides form opposite rays. Angle 3 and angle 4 are a linear pair, and because they're non-common sides form straight line, and because they're a linear pair postulate also tells us they are supplementary. Angle 4 and angle 5 are also a linear pair and supplementary. In the next problem, we're finding missing angle measures. It says angle ABC and angle DBC are a linear pair. So by definition, linear pair says that they have one side in common, but their non-common sides are going to form a straight line or a straight angle, which is going to be 180 degrees. So linear pair postulate says these two angles add together to be 180 because they're supplementary. So the measure of angle ABC plus the measure of angle DBC has to equal 180. Now let's substitute into this equation. The measure of angle ABC is 3x plus 19. The measure of angle DBC is 7x minus 9. That equals 180. Let's add like terms. 10x, positive 19 and negative 9 is plus 10. Subtract the 10 from both sides. 10x is 170. Divide both sides by 10. X is 17. That's not what the question's asking for. The question's asking for the measure of angle ABC and angle DBC. The measure of angle ABC is 3x plus 19. Substitute the 17 in for x, and you're going to get the measure of angle ABC is 70 degrees. Measure of angle DBC is 7x minus 9. Substitute the 17 for the x again, and you will get 110 degrees. And 70 plus 110 is 180, which is how you can check your answer. In the last problem, we're using an angle bisector to find angle measures. It says that ray LM bisects angle JLN. So let's draw a picture of angle JLN and a ray LM bisecting that angle. So if the measure of angle JLM is 42, then what is the measure of the larger angle, angle JLN? Well, the measure of angle JLN is going to be 2 times the measure of either of the angles that makes it up, because it's bisected. They're congruent. They have equal measures. So 2 times the measure of angle JLM is going to be 2 times 42, which is 84 degrees.